Okay, today what we're going to do, start 4F, using the general rule for finding the nth term of a geometric sequence. So just like a arithmetic sequence, there's a pattern here that we can use to be able to find any term. And that pattern is found by thinking about what operations are creating the sequence. And if you'll remember that for a geometric sequence, we have that common ratio. Again, called the common ratio because if you divide the next term by the previous term, you find out what multiplier you're getting. So you find it by dividing, which is why it's a ratio, but in reality, it's a multiplier. Right? So you're multiplying something over and over and over again. If that's the case, remember that repeated multiplication by the same number is an exponent or an index, depending on which term you like to use. So if you're multiplying over and over by the same exact number, then you're you're using an exponent. So say, for example, let's consider this. If the first term is a, then that means that you're taking a times r to the 0. Remember that anything to the 0 power is 1. So a times 1 just gives you a, in other words, the first term. For the second term, we're taking a times our r, which is that common ratio, and a, which is the same as saying a to the r to the first power, because remember, anything to the first power is the number itself. For the third term, you're taking a times r times another r, which written as an exponent is a times r to the second power. And you can continue that same pattern infinitely. But instead of writing out the expanded version, which is what we have here, we can use this exponential version to create a pattern for any geometric sequence. So you see that as you move forward, every time that the number here goes up, then the exponent goes up. But because we're starting at r to the 0, in other words 1, then the first one is 1 less than the original number here, our n. So let's write that out as a pattern. So t to the n, so any term, can be found by taking a times r to the n minus 1. So it's always 1 less than the term number you're looking for. So it makes a very straightforward pattern for us to be able to find any sequence. But remember, this is only if we know a and r. So sometimes you're going to have to look at the pattern and find your a, your first term. Sometimes you're going to have to look at the pattern and determine that common ratio r. Sometimes they're going to give you a value, which you're going to have to replace the t to the n and then find one of those. Okay. Other times they're going to give you two equations with two unknowns, in which case you're going to have to use simultaneous equations. Now remember, because this is multiplication here, when you do simultaneous equations with multiplication, then you're going to be taking things apart using division instead of adding or subtracting. So think about it. If I wanted to get rid of this a, then I could divide both sides by the a, or divide away the a. Okay? So be careful when you're doing those, when you're working with these. It's not always just subtracting like it was in the arithmetic sequence. So if you had 5 equal a minus r, for example, I could get rid of the r by adding an r, right? But if it's multiplication, you'd have to get rid of it with division. Just a little hint as to what you're going to run into when you start doing your homework. There you go, and you have your homework list, so just do the assignments for 4F as outlined, and we will see you next time.